Hello and welcome. In this video, I'll be working through the Unit 6 test review and any and all solutions or formulas you might need to know while working through it. So before I start, I might recommend you have a unit circle, either filled out or blank, somewhat handy for you, as well as a calculator that you'll have easy access to. So without further ado, let's go ahead and jump into this first group of 4 questions, which utilizes one of those unit circles I just said to have access to. So for this grouping, technically you could do this without having a unit circle. We could do it by just visualizing where the angle would be. So 150 degrees in this case would be like the last angle before 180, just to kind of give you the visual. And if we're comfortable with what the unit circle looks like, we could now just picture what the x and y would be. So for this one, the x and y would be rad 3 over 2 with a negative on it because it's to the left, and then the y value would be a positive 1/2. So since the sign is the y, I know it's going to be the 1/2. The other option I could do is just open up a unit circle and focus my attention on the angle that it was asking about. So 150 is right here, and the y value is, as we just saw, or just kind of estimated, would be the 1/2 that we have right there, hence my answer of 1/2. If we move on to the next one, 210 degrees would essentially be this angle that's actually in the third quadrant, 30 degrees more than 180. And if we think about what tangent is, tangent would really be like the slope of that line, or it's the y value divided by the x value. And if we think of what our options are for tangent, remember it's ones or negative ones in the middle. It's square root of 3 for the steeper angles, so this one must be the square root of 3 over 3 because it's the less steep of the 3 options. And since tangent goes with slope, it must be the rad 3 over 3. Or, as mentioned before, we could just reference on a unit circle. The 210 degree angle is this angle right here. And notice we have the tangent on the outside, which would be the y value divided by the x value, which reduces to this rad 3 over 3 if we rationalize appropriately. Moving on to the third one here, cosine of 7 pi thirds. Well, 7 pi thirds actually is too large for a unit circle. So what we would want to do is figure out what it's coterminal with. And the way that we would do that is by subtracting a rotation. So remember, one rotation would be 2 pi. In this scenario, though, because fractions are involved, I would need to get a common denominator. So I'd have to multiply the top and bottom by 3 to make a common denominator of 3. And now it's really 7 pi take away 6 pi, which would really be identical to 1 pi. So cosine of 7 pi thirds should be identical with cosine of pi thirds, and pi thirds, if I were to sketch it, should be the steeper one in the first quadrant. And again, cosine now is going to be our x value since sine was the y value. And in this scenario, I hope we can kind of picture like that's not going to be as far horizontally as it is vertically, so the x value must be a 1/2 since it's not one of the pi fourths, which was the rad 2 over 2s. And again, mentioning the unit circle, if we had an access to it on the test, we can go ahead and just picture where that angle would be. And since it's cosine, I would just focus my attention on the x, which, as you can see here, is exactly 1/2. The last one here, sine of 5 pi thirds. 5 pi thirds is one that is on the unit circle. It's actually in the fourth quadrant. It's that pi thirds. Remember, all the pi thirds are close to the y, whereas all the pi 6 are all close to the x. As far as the axes are concerned. So 5 pi thirds would be this steeper one here in that quadrant. Sine is the y value, so since it's below the x-axis, I know for sure it's a negative, and it should be the larger value compared to the horizontal position, since the horizontal position doesn't seem like it would be as far, so negative rad 3 over 2. Or picturing it on the unit circle as we've done on the other ones, it would be this angle bottom right. And since it said what is the sine, it would be focus on the y, which is in fact negative rad 3 over 2, as we've already answered. Moving on to now number 5. So number 5 provides us with a secant ratio, so we could right off the bat know what our cosine ratio is. So the cosine ratio would just be the reciprocal of that, so cosine of theta must be negative 3 over the square root of 34. We could also picture, like, since this says it's in a quadrant 2 or second quadrant, we could just visualize drawing the triangle in that area, or technically I now have the ability to say that my negative 3 must be the adjacent side and the rad 34 must be the hypotenuse, and just make sure that my angle when I draw it is the one that happens to be at the origin. So if I go ahead and just sketch a right triangle. It doesn't have to be perfect. It just goes into that quadrant. I would need to figure out what the adjacent and hypotenuse would be. So my reference angle is, again, the one with the x-axis at the origin. So that means this horizontal leg must be the -3. And then the rad 34 would go on the diagonal, or the hypotenuse. So at this point, I would go ahead and just utilize Pythagorean theorem to solve for that last side. So it would be the square root of 34 squared being equal to -3 squared added with, since this is a y value, technically it would be just y squared. Doesn't really matter what letter you use right there. We're just trying to solve for that last side, so you could call that A or B, doesn't matter. From here, notice we end up with -3 squared would be 9, so I need to take away 9 from both sides. Square root of 34 squared is just a 34, so really this is just 34 take away 9, which is 25. And if 25 is equal to y squared, I could take the square root and get the 5 should equal y. It could be positive or negative, but based on location, since it is quadrant 2 and that's above the x-axis, I know for sure that would be a positive 5. And now at this point we have all 3 sides labeled, so I should be able to do any of the trig ratios from here utilizing SOHCAHTOA. So for the first one, sine would be 5 square root 34 over 34 if I were to rationalize. Keep in mind that would have been 5 over the square root of 34, but I feel like we hopefully have done that enough times that we just know that the radical would go to the top and then no longer have a radical on the bottom. It is positive because of the quadrant as well. Cosine we've already answered, so this would be -3. I guess I didn't rationalize it technically, but it would be -3 rad 34 over 34, similarly to what we had to do with sine. The tangent value would be the y value divided by the x value, so that would be 5 over a -3, so -5/3. And now it's just the last two are the reciprocals of whichever function they correspond with. So cosecant is the reciprocal of sine. So if sine was the 5 over the square root of 34, this would be a square root of 34 over 5. So that would be a little easier to use the first version before we rationalize than the most recent one. And then cotangent is just the reciprocal of tangent, so if that was -5/3, this would be -3/5. Moving on now to number 6. Number 6 isn't a whole lot different, it just presents things in a slightly different way. This one actually gives us an ordered pair, so I'd go 3 to the right, and then 4 down, and then put a dot. So it says that I have this angle in standard position, so that means it technically starts on the positive side of the x-axis and goes around, and it says that that point is just somewhere on the terminal side. So technically it's the angle that goes all the way around, but technically we can just use the angle that's at the origin. If I were to draw this right triangle, it would just be this angle that's on the inside right there as like my quote-unquote theta. So for this one, if I know that I'm 3 to the right, that means my horizontal leg must be, if I were to draw this off to the side a little bit more clearly, would be my +3, my vertical edge would be my -4, and if I square both, add them together, I'd end up with 9 plus 16. So 9 plus 16 would get me up to 25, and then take the square root of that, so that should give me a hypotenuse that's equal to 5, utilizing Pythagorean theorem. So at this point I should be able to figure out my sine, cosine, and tangent again for this reference angle that would have been at the origin. So let's see, sine would be the opposite over hypotenuse, so that must be the -4 over 5. Cosine would be the adjacent over the hypotenuse, so +3/5. And then tangent would be the opposite over the adjacent, or the -4 over the 3, so that gives me a total of -4/3. For number 7, this one just wants us to come up with a couple of coterminal angles. So it does say specifically I just want one that's positive, one that's negative. So there's lots of different possible answers here, but I would just say go with what makes the easiest possible approach for you. So if 221 is our starting value, or that's the angle we're trying to be coterminal with, if I wanted another positive one, I would just add one more rotation to it, so we can do the mental math on that, and hopefully see that that would be 581 degrees. Make sure that we are including units, because remember, now that we have radians as a part of our class, right? If we don't see radians, it would be implied to be radians. If I see a degree mark, if I don't see degrees, then it's implied to be radians. And in this case, it's supposed to be degrees, so just make sure that you include the degrees. If I wanted to do now my negative angle, it would just be, again, start with the 221, but this time instead of adding 360, we could take away 360. And at this point, we could technically let our calculator confirm these two things, so I'm going to go ahead and just kind of show those two things. Adding 360 does confirm the 581, and then the 221 minus 360 would get me negative 139. And overly, or hopefully not overly complex, but technically we could add a couple of 360s, so I could have technically added two 360s to get a positive angle, so I could have had something larger than 581, or I could have had something less than negative 139 if I subtracted more 360s. But again, like I said, when it comes to answering a question like this, just do what's easiest, try and come up with whatever the next positive one would be, or maybe what the first negative one would be. I think that's by far the easiest way to approach it, even though there technically are multiple angles that could be correct answers for these. The next couple of questions, number 8 and number 9, just want us to do some conversions. So remember, our conversion is basically taking advantage of either every 2 pi is the same as 360, or we could also do every pi is 180. It really, for the reduced version, is best to use that pi and 180 connection, where it's pi radians for every 180 degrees. And then we just need to think in terms of what unit am I trying to cancel and how do we get out of it. So with this one being 175 degrees to start, that kind of tells me when I multiply, I would want to have degrees in the denominator, so that means 180 must be in the bottom, which then tells me pi needs to be on top. And then from here we could let maybe our calculator just do the reducing for us. We know our answer is going to be something in terms of pi, so we could just set up the template that way, but also on the calculator we could just, if I clear that out, bring up our fraction template. 175's on top, 180's on the bottom. Let it do the work, so I get 35 on top, 36 on the bottom. So it'd be 35 pi, 36. If we look at number 9 here, now this time it's actually starting in radians, and I want to convert it into degrees, so I'd start with the 2 pi ninths. Multiply it. This time I would want to have pi radians in the denominator, so it cancels the radian unit. We can actually kind of see physically here that the pi's would cancel, not that they had to have a pi to start, but that's kind of convenient with this one. And now it really just turns into what's 2/9 of 180. So once again, we could just type in 2/9 times 180, and if it still is a fraction, convert it. But with this one, 2/9 of 180 gives us 40 on the calculator, so this is going to be a 40-degree angle. Moving on now to number 10. Number 10 wants us to come up with an arc length. So this is one of those questions that will require us, because it needs the length of an arc, or arc length. We will need to know a formula. So for this one, this is the S is equal to R times theta formula. And again, specifically, if we remember in the notes, the theta does need to be in radians if it wasn't provided in radians. The R, on the other hand, can be whatever unit it needs to be. So in this case, it's a radius of 17 millimeters, so I know that my arc length is going to be in millimeters. So technically, we could set up our answer key with the correct unit before I even start worrying about doing any of the math. Now from here, I would just take whatever they've provided for us. So they did provide me with 3 pi fifths as my theta, and then a radius of 17. So this is my R, this is my theta, so ultimately my arc length is just going to equal the 17 times 3 pi fifths. And now I can go ahead and let the calculator do the work. Really, it just seems like it's going to be 17 times 3, because 5 can't reduce with either of those. So 17 times 3 in the numerator would give me 51. So this must be 51 pi fifths. And if we wanted to figure out what that is as an approximate decimal, we could, but ultimately I think it's just easier to just leave it in terms of pi, so why not just call it 51 pi fifths millimeters for this one. Moving on now to number 11. This one just wants us to compute the linear speed. So instead of it using the S formula, this one's going to use the V. And V, if you recall, had 3 different options. One of them was, what is the arc length just divided by the time? That would get us our linear speed. The other option we could do is substitute what we know S is equivalent to, which would be R times theta over our time. Or yet again, we can go with r times, since omega per time, or sorry, the theta per time is equivalent to omega. That would just be our angular speed. So kind of depends on the question as to which of those three is the most useful. So I'm just going to write down all three just in case. Now for this one, it looks like it gives us a 30 rotations per minute. So I'm going to have to convert that into a theta. So if I maybe just do that really quick, our theta in this case is going to be, actually this is going to be more of an omega because it is a per minute as well. So I could go with 30 times, each rotation is 2 pi radians per, and then it's 1 minute. So for this one, it looks like it would just be 60 pi radians per minute. Now it wants us to figure out what this is in inches per minute, so hopefully the radius that they provide us is in inches, which in fact it is. It does say 5 inches here, so our velocity for this one is just going to equal our radius times our omega we just found, so it would be 5 times 60 pi radians per minute, and that should give us our arc length, which is actually going to be in inches, so it's going to be inches per minute. May as well get that unit going, and 5 times 60 would take me up to 300 pi, so 300 pi inches every minute would be the linear speed of that specific point that's 5 inches from the center of that record. So that finishes up everything that would be a part of the first standard. Moving on now to the second half of the test, or the second standard that will be on it, which is all about now the graphing of those 6 trig functions. So being able to remember which formula goes with which for as far as like amplitude, period, phase shift, vertical shift for each of the 6 functions is going to be key for the remainder of this. So each one I'll just try and at least present like here's what the formula would be, and then also mention how we can modify maybe our graph to match whatever grid has been provided. So without further ado, let's go ahead and get going. So for this first group of 3 questions here, notice it's just giving us a sine function. So with the sine function, we should be able to identify an amplitude, a period, and any shifts if I had any. There is no addition or subtraction, so in this case I only have the amplitude. So amplitude is just the absolute value of the A, so that would be this number in front. So absolute value of 2 is still just 2, so that means it's going to go as high as 2 above the midline and as low as 2 below. The period for this one should be for all the sine, cosine, secant, and cosecant functions should be 2 pi divided by the b value. In this scenario, I could picture this like it's really 2 times sine of 1/4 times x, if that's helpful to picture. Dividing by 4 is the same as multiplying by 1/4. That makes the identifying of this b value a little bit easier. It should just be 1/4. And then we have to now multiply by its reciprocal to do the division by that fraction. And if I go ahead and do that, 2 pi times 4 is in fact 8 pi, so this has a period of 8 pi. So now the question comes down to, if I scroll down a little bit for the graph itself, is do I go every line and plot points, or do I go every other line and plot points? And that basically will just come down to where is the period. Is it on the 4th tick mark here, or is it on the 8th line's tick mark there? If it was on the 8th line, then that means I would go every 2 to go through our sequence of mid to high, back to mid, back to low, and so on and so forth. But with this one, since it actually is only utilizing 4 lines, that means actually every single line is going to be something plotted on it, or will have something plotted on it. So for this one, sine, if we think of what happens on the unit circle, sine on the unit circle should be this point over here is 1, 0. The y value is the sine, and then it technically, as I go to the right, or as I increase the angles, it should go up towards +1 for that. So that tells me that I'm going to start at 0, and then 1/4 of the period later, which happens to be one of these lines, or one of these tick marks horizontally, I'm going to go to the next sequence, or next part in the sequence, which is either going to be a high or a low if that's a mid. So sine normally should go to a high. The only thing that would maybe change that is if I had a negative a value in front, because it would have flipped it upside down. There is no negative with this one, so I know it does go up to a high. And again, notice instead of going 2 lines to the right, it's actually just 1 line because my period here is 8 pi on the 4th tick mark. And then from there we can go ahead and continue the pattern. So if it went mid to high, I'd have to go back to mid, followed by a low, back to a mid. So that would be 1 full wave if I were to try and like at least sketch what 1 full wave would look like. I'm going to go ahead and continue the pattern each direction from here. So I'll just continue going to the right and then come back and do the left side, where it will just keep alternating back and forth between a high, a mid, a low, a mid, a high, mid, low, mid. And if I go back the other direction, it would be, if it was a high, then a mid, then the one before needed to be a low, and then just continue the pattern. Mid, high, back to mid. And I should be able to now just draw a nice and smooth curve that goes through all of the points. Again, remember hills, not mountains, because it does need to be a nice and smooth graph for this to truly turn into a wave. So try and avoid the very rigid things like that. Show that you at least understand the idea of it does go nice and smooth through these values as it passes through each high point or low point. Let's go ahead and try out the second graph here, this grouping here from 15 to 19. Now I actually see some addition or subtraction, so not only will I have to worry about amplitude or period changes, but I also have the ability to potentially worry about phase shifts or vertical shifts. So remember, phase shifts are like horizontal shifts, and vertical shift, pretty self-explanatory, that's going to be something up or down. So just like before, as far as the formulas that we would use, I've got the absolute value of A is going to be our amplitude, so that should just be a value of 2. This is a cosine function, so that tells me I should use 2 pi divided by b to represent my period. So for this one, it would be 2 pi divided by the 2 that's in front of the x, which reduces to pi, so I know my period is pi. My phase shift for this one is going to be the c value divided by the b value, but also need to mention which direction I go based on do I see addition or subtraction. So my c value divided by my b value would be pi halves divided by 2, which gives me pi fourths. And then now I just focus my attention on what operation do I see. Well, I see subtraction there in the middle, so that should mean it is being moved to the right pi fourths. And then my vertical shift in this case is 3 down. Due to the -3, it's just whatever that value of d is. So I'm going to go ahead and just on my answer blanks, just to make it clear, it's pi fourths to the right for the phase shift, and then not 5 but 3 down. So if we go ahead and start putting those things into action there, remember I didn't see or didn't have a negative. This is already a grid that's been filled out, so now it's just a matter of is it the 4th line or is it the 8th line for my period. Well, the period was pi. That happens to be on the 4th line, so that basically means I'm going to use every single line just like I did on the last example. If it would have been down here on the 8th one, then I would go every other line as far as when it comes to plotting the key point. So again, just always keep an eye out for what is the grid counting by and make sure that you adjust accordingly. Now, pi fourths on this grid is actually equivalent to one of those lines, because if the second line is pi halves, the first line technically is pi fourths, so that does help me account for my phase shift. And then I do have the shift down 3 that I'll go ahead and account for. So I'm going to go ahead and just kind of draw a nice little midline that's down those 3 spaces. That way all of my midline points will fall on that. And then now it just comes down to where is the first point supposed to be. So for a cosine function, again this was, I know we can't see it because it can't fit on the screen at the same time, so it was 2 cosine of 2x minus pi halves minus 3. So with this one, since it's a cosine function, it should start at either a high or a low. Since it's a positive 2 in front, that means it should normally start at a high, so I know it will be or would have normally been at this point right here, but that has to be shifted down 3 places, but also to the right pi fourths. So if I go and just kind of picture where that would go to, if I started there and counted down 1, 2, 3, and then to the right 1 pi fourth, my first point that I plot should in fact be that point right there that you can kind of highlight, or I can highlight and make it see, or make you see a little bit easier. From there now, since that's a high point, the only option I really have is whether I go to the right or to the left. It should come back down to a mid. So the midlines, remember, are all going to be at this -3 value, since that was the shift down 3. So if I go to the left or to the right, there we go. We've got two parts of this. This is like the top half of the wave that's been plotted, and now I can continue either direction. But again, remember, I'm using every line, not every other line, so it's a little bit different than maybe some of the problems we've done in our homework. So again, I was a high, mid, so going backwards I've got a low, followed by a mid, back to a high, back to a mid. And this is where utilizing the amplitude also is becoming helpful. I know I just go up or down 2 from this dotted line that I started the graph with. So if I continue now to the right, I was a high, followed by mid, so low, mid, high, mid, low, mid, high, mid, low, mid. There we go. We've got all of our points plotted. Now it's just a matter of, again, just drawing nice and smooth curve through the points, making sure, again, to draw hills, not mountains. And there we go. We've got a nice smooth curve that goes through the points. Not the perfect curve, but still at least gets the point across of where my points should be. You can clearly see that my midpoints or midline points have been plotted in the right spot, as well as my highs and lows. So I'm not going to be overly picky. I just want to at least see that you have the curvature of this graph, making sure that it's nice and smooth, as I mentioned on the last example. Moving on now to 20. This one now is just wanting us to graph a tangent graph. So it could be tangent or cotangent when it comes to tests. They're both going to be fair game. They're very similar in approach. So remember, tangent is something that should normally come up the page like that. Cotangent would be something that comes down the page, conversely, but since this is a tangent and the value in front of it is positive, that does tell me with 100% confidence that it should come back as some shape that comes up the page through all of the zeros that I end up plotting. I don't see any addition or subtraction, so that also tells us that we don't have any shifting to worry about. So this really is just identify what the A is. That's going to tell me how high up I go at maybe those quarter values, or potentially low. But it also should allow us to solve for our period. Remember, with tangent functions, or even cotangent, instead of 2 pi over b, now it's actually going to be 1 pi over b. So for this one, it would be pi divided by the 5/2 that's in front of the x. And just like we had before, it would be keep the top the same, flip the fraction on the bottom, 2/5, and multiply. So that tells me that I have a period of 2 pi fifths. Again, looking at our grid, we need to see, is that the 4th line or is that the 8th line? If it was the 4th line, then I'm going to use every single one to plot something. If it's the 8th line, then I'd go every other. It looks to me like it's on the 4th line, so it means I'll utilize each tick mark instead of skipping. And with tangent, again, we could fall back to unit circle and just go what happens at 0 degrees or 0 radians. The tangent at that value is 0, and then as I go up, halfway between is a 1, and then the next one would go undefined, which, remember, undefined values are actually going to be asymptotes with these specific graphs. So best way to graph a tangent, though, is actually just take advantage of whatever I've done first, or whatever the first thing is, which should normally be at the origin unless it was shifted, is just plot those zeros or midline points and then count whatever the period is out and just plot the same thing. So since this is every 4 lines is 2 pi fifths, 4 lines later is going to be another x-intercept, followed by another one 4 lines later after that, and another 4 lines after that. So I can basically get all of my zeros plotted with relative ease, again just making sure that I know that my period is 4 lines, not 8 lines, just in case it happened to be slightly different. Now exactly halfway between 2 zeros, if I did continue on the unit circle, I get -1, then followed by 0 again. So notice halfway between 2 zeros is an undefined value, so that's actually going to be something we take advantage of and just draw those vertical asymptotes exactly halfway between the x-intercepts we just plotted. Now from here, it's just going to be take advantage of either having a value of 1 or -1 that's going to get multiplied by the 2 that's in front. So technically it will turn into a 2 or a -2. And just making sure that our graph, if we go back to the beginning, remember it was supposed to be something that comes up the page from left to right. So if I already have one of the points plotted, it should come up and to the right. So I could just go right 1, up 2, get that point. But I could also say go down to left, or sorry, down to left 1. That gets me another point. So now I can create that vertical stretch of 2, but also making sure that it's still coming up the page like a tangent should normally do. And now it's just a matter of repetition in between each set of asymptotes, and make sure that, again, each part of the graph technically is coming up the page and not crossing over any of those vertical asymptotes that we've graphed. And at this point, we should have enough stuff graphed that we've got everything filled out from left to right. We have an A value we can see physically of 2. It's going up 2 at those halfway in between the zeros and the vertical asymptotes. And it was a tangent graph. It did start at the origin, so everything seems to check out before we move on. And now moving on to the last 2. These ones are just going to be kind of a, if I give you a function and a set of graphs such as this, it's just being able to narrow down appropriately what that function should, 1, look like, but 2, which one has all of the same parts that we needed it to have in order for this to be graphed appropriately. So each one of these, what we would look to see is like what maybe the period is and which direction should it go. So cotangent function should normally come down the page. So if we know that it's supposed to come down the page, that should rule out a couple. For sure it can't be a B, and it looks like it can't be C either, because it looks like those ones are actually a tangent graph. So now it really just comes down to, okay, if that's what we have going on here, it looks to me like the period for this first one, if that's at pi thirds, half of that would be pi 6. So it seems to me like it's going every pi 6 from asymptote to asymptote, or we can even go x-intercept to x-intercept, but one full cycle seems to be happening inside of pi 6. Sorry, that didn't look like much of a 6 there. Whereas this one at the bottom right, which is the other option, looks like that's actually happening every pi third. So really it just comes down to what is the actual period. So my period, remember, for either a tangent or a cotangent should be pi divided by b. Go ahead and move that over here maybe, but just to explain, like, it should have that shape anyway. But here it would be pi divided by the b value, which is the 6. And so which of those did we identify to be pi 6? Well, the second one here was pi thirds, even though I didn't write it. So it seems to me that must be A, it can't be D. For 22, notice we're just switching functions. Now it's actually just asking us to identify which one is appropriately a secant function. So again, secant function should be something that if we thinking like, what should I plot? Well, it would be all of the x-intercepts, or sorry, not the x-intercepts, but all the points of cosines. So it normally should be a high point, and then from there a couple of zeros followed by a low point. So sketching wise, it should have a U that crosses the y-axis, and then the next one should be an upside down U just a little bit to the right or to the left of whatever the first asymptote is. Now the actual period would be how far it takes to go from this point here to this point here. So it really actually is going to be that length from here to here. That's going to be something that I would keep track of. So if I were to maybe at least narrow this down to which ones actually are secant graphs, looks like letter A must be a cosecant graph because it doesn't cross at the y-axis, so that rules that one out. Same thing with letter C right underneath it. It should have crossed at positive 2 since that's the A value in front, so that rules out those two. So now it's just a matter of which one has the correct period. So period for secant and cosecant is the same as sine and cosine, where it's 2 pi divided by b. So it'd be 2 pi divided by the b value, which looks like is a 1/2, because dividing by 2 is the same as multiplying by 1/2. So that's going to be, keep 2 pi, flip the 2 over 1, and multiply, so I get 4 pi. So now I'm just going to look at which one from low point to low point of these U shapes has a length that's equivalent to 4 pi. So it looks like letter B, if I were to count horizontally there, that actually was 8 pi from point to point. The second one here for letter D looks like it actually is the 4 pi that I'm looking for or shooting for. So that means it should be letter D, not letter B. Anyway, hopefully this has been helpful when it comes to preparing for the test, but as always, if you have questions, just please seek me out. Let me know what I can do to help out. But at least this should give you an idea of here's some of the formulas I need to know, so you know what to spend a little time on, but also gives you at least a little bit of a approach to how to approach some of the, or how to see some of the questions and get them started, at least moving in the right direction. So anyways, appreciate you taking the time watching the video. Hopefully this helped, and we'll catch you next time.